and hit record. And I'm going to share my screen because what I was looking at is Python, Anaconda's website. And I meant to share this to you and I blanked on it. I'm so sorry. Coffee has not quite kicked in yet, I guess. So if you Google Anaconda or just go to anaconda.com, Anaconda is a distribution of Python that comes with a bunch of awesome things, including Jupyter Notebooks, Spider, RStudio, and a bunch of other things. So if everyone will go ahead and download it and install it, we will move forward with it. I am updating mine by using conda update conda in the terminal. When we install packages and stuff with Anaconda, you can do it one of two ways. And I'm going to show you how to do that in a minute. When everyone is done downloading and installing Anaconda, please put a message in the chat window. Excellent. Well, while people are installing, let me talk a little bit about what Python is. Python, like R, is an open source programming language. Now, Python was built specifically by and for engineers. Python is a functional, Python is an object-oriented programming language, where R is a functional programming language. And I'm going to show you how they're different. Python has objects in it that all have methods and aspects to them. And I'm going to show you how that works. Python has a bunch of packages that can be used to extend Python's capabilities, including NumPy and pandas and matplotlib. These are all packages that I'm going to talk a little bit about today, and I'm going to go into more detail with next class. So I'll be teaching a second Python class next week, probably exact same time on Friday. But Python is a pretty extensible language. One of the things that Python was used to build was Dropbox and Netflix. Python is a pretty cool language. But Python and R are the two big programming languages that people use for data science. don't forget to send me a message when everything is installed. Python also includes this package called scikit-learn, which is one of the largest open source machine learning packages there is. And so generally when I'm doing machine learning, I use Python. You can also use Python in combination with TensorFlow, which is a big package for creating neural networks. And I'm sure everyone has seen the memes on Facebook where it's where a bunch of like scripts or something were fed into a neural network and a neural network created a new script. Maybe. Everybody's so quiet. Okay, cool. So we just have one installation to finish, and then we'll go ahead and get started with Python. You can see mine is updating. I know that Glenn is on a Linux machine, right, Glenn? Tavi, what operating system are you working with? Windows. Okay, cool. And Oskia, are you also on Windows? Cool. All right. So for those in Windows, when everything is installed, in your start menu or whatever, you're gonna have an icon that looks like this. Little circle. It's green. It's got like scales on it because it's meant to look like a Python. This is Anaconda Navigator. I want you to go ahead and open up Anaconda Navigator. All right. And when you open up Anaconda Navigator, it's gonna look like this. Was there a question? Everybody have Anaconda Navigator open? Okay. Well, when you open up Anaconda Navigator, it's gonna look like this. Well, we lost his skin. You're gonna see Jupyter Lab, Jupyter Notebook, PyCharm, IPy, Spider, GlueViz, Orange 3, and RStudio. Now, a lot of these are going to have little launch buttons underneath them, and some of them are going to have install buttons. You should have a launch button underneath Jupyter Notebook. If you do not, send me a message. Okay, but before we get into Jupyter Notebook, which is what we're going to use today, I'm going to go through a little bit of what Anaconda Navigator looks like and what everything does. So you start out on your home screen, which has all your applications. Jupyter Lab, Jupyter Notebook, PyCharm, IPy, and Spider are all IDEs for Python. All of them allow you to run code. Now, for those who were here for class last week, Spider looks a lot like RStudio. So I'm going to go ahead and launch Spider. I am not suggesting that you launch Spider. I'm just going to launch it and show you. I'm not actually going to work in Spider today. I kind of hate Spider. So Spider looks a lot like RStudio in that you have a place where you can write code, you have a console, and you have your environment with all your variables. And like you can get documentation and stuff here, and you'll see all your plots and your files. I don't like Spider because of the way that it seems to be unstable with code that I write. That doesn't mean that it is unstable. It's just Spider has burned me in the past, so I generally don't use it. That's not to say that it isn't a good IDE. I know lots of data scientists who use it and love it. I'm not going to use it today though, but I wanted to give you a tour of it just in case. You can see I was running some NLTK in Spider. NLTK is Natural Language Processing Toolkit. So I was doing some natural language processing in Python the last time I was playing around in Spider. Excellent tagging, that's awesome. Okay, so now that we have looked at Spider, what we're gonna end up playing in is Jupyter Notebook today, but before I do that, I'm gonna show you your environments. So your environment section, especially if you've just installed, is gonna look like this. Or not gonna look like that, it's gonna look like this. You're gonna have a base with a little button that looks like a play button next to it, and a list of different packages that are installed. The ones that are all so you can look through this list of installed versus uninstalled by using this drop-down menu. So you can click installed, you can click not installed, you can click updatable. You're gonna see I have a bunch that are updatable. I can click all and see all the different packages. I can search for packages here. So if I was going to install new packages, I could look for NLTK, for example. I've installed NLTK already, but you could look for that. You could look for scikit-learn. And I've already installed scikit-learn because it's got a little check mark by it. But if you wanted to install a new package, all you have to do is search for it here and click the checkbox next to it, and it will ask if you want to install it. And then you go through the process to install it there. Now you can also install it from a terminal by clicking on the play button here and then opening a terminal. And if you want to install anything in Anaconda, you would type in conda install and then the name of the package. We're not going to do anything, any installations of packages today. I'm going to walk you through installing NumPy and Pandas next class if you don't have it already installed. But we're not going to install anything today. Get out of that. Okay, so these are all the packages that are possible in your environment. There are also other packages that may not be listed here that you could install either with conda install using your terminal or using pip install. For anyone who's used Python before, you may have heard of pip install. Pip install works just fine with Anaconda as well. I suggest using conda install first, and if it doesn't work, use pip install, but generally they both work pretty similarly. Now, I'm going to go back to my home, okay, and then we can go to the learning section. These are a bunch of different documentations and references, as well as training section, the training section. You can go through training in Python using Anaconda. You can watch a bunch of videos. So Anaconda comes with a lot. And then if you click on community, there are a bunch of different groups and conferences for Python, including PyCon, which happens basically in every city. There's a PyCon DC that happens every single year in August. And you don't have to, if you can apply to present at PyCon, even if you're coding not in Python. I coded all in R when I presented at PyCon DC. But there are also lots of forums. You can find people on Twitter. Lots of really cool stuff here. Okay, so we're gonna go back to home and we're gonna launch Jupyter Notebook. Eskia, did you get everything installed? Okay, so after we have Jupyter Notebook open, you'll see the list of possible files and folders that you could open. I'm not going to open any of these. I could go to my desktop, for example, and open any of the folders on my desktop. But what I'm going to do instead is I'm going to create a new Python notebook. So I'm going to click this new button over here on the right and click Python 3. So you should get something that looks like this. And so what you can do is you can click the Untitled and change the name of your notebook. And you've got this little cell here. Now, let's look at the menu up here. So in this cell, right, the cell looks gray and you've got an IN and square brackets next to it. And the square brackets are empty and the cell is empty. Now, just like RStudio, or just like R, Python could be just a glorified calculator. So I'm just going to do. And to run the code in that cell, I can either hit Shift Enter, or I could hit the Run button. Again, 3 plus 3 is 6. So Python, we just used Python as a glorified calculator. Now you can see that the particular, the code that I ran now has a number in the square brackets. And the number here is 2 because it's the second thing that I ran. It's also the first thing that I ran, but it gives the number is based on the time run after you've opened up your notebook. It then has a new section here that says out. And we can double click that output to hide it. And the out, the number inside the square brackets for out, corresponds to the number for your input. So if you run a set of code and you're supposed to get an output, the number that corresponds to the set of code that you just ran is the number that will show up in the output box. Okay. Now that we've used it as a glorified calculator, let's look at the menu up here. So we've got a save button, so we can save our notebook. We've got a plus button, and the plus button is going to add a cell below the cell we're in. So I had this cell selected, so we added a new one. We've got the cut. We can cut selected cells. We can copy. We can paste. We can move cells up and down. The run button, we've already seen how that works. The stop button is for if a particular cell gets stuck. And that happens sometimes, or like sometimes code that you write takes a really long time to run. And so you can do what is called a keyboard interrupt by hitting the stop button, and it will interrupt the code that's running. Or say you started to run a set of code that you didn't mean to run. You can hit the stop button and make it stop. You can restart the kernel. Now, each one of our notebooks has its own kernel. And the kernel is where all of the memory for your particular notebook is being held. After you open a notebook, the kernel is going to be completely clean. Even if you've run that notebook before, the memory that your notebook originally had is going to be wiped clean. Now, that doesn't mean that your notebook is not going to have the code that you wrote in it. It will still have the code you wrote in it if you saved it. And it'll probably still have the output unless you told it to erase the output. But it will not have any memory. So if we declare variables, which we're going to do in a little bit, it will not have those variables in its memory yet if we restart our kernel or right when we open up our notebook. So we'll have to rerun the code that declares our variables if we want to have those. We also have this drop-down menu here. Right now it says code, but we can change our cells to be from code to markdown to raw to heading. Any of these are good options. If you change it to markdown, right, it's no longer going to have an in next to it. It's also not going to run any Python code that you type in there, even if you hit run. So like this, I put in, It's just going to display whatever it is that I typed in. It's not going to run that code. If you get to a point where you have created a cell that is a different format than you wanted, for example, I created a markdown cell here and I really wanted a code cell, you can select the cell and then select what kind of cell you want it to be from the drop-down menu, and it will change it. And now we can run it just like any programming cell or any coding cell, because it's a coding cell. Now, I know two of you were in class last week, and so you know a little bit about programming. Tabby, I don't know your background. Have you done programming before? I think you're on mute, love.
Oh, sorry, that was chat. I've worked in software engineering for 10 years. I'm real experienced at coding.
Awesome. Okay.
But like I was saying in my message, I haven't used Python since college, so I thought it would be good to get a refresh on how it works and kind of an update on what it's used for now.
Awesome. Awesome. Well, so today is going to be a real, like, super easy class for you then, because we're just going to go through some basics in Python. Okay, so Jupyter Notebooks are awesome, and they're awesome for a lot of reasons. I love Jupyter Notebooks because they allow me to put all of my code, the text that I want to write about the code that I wrote, and my graphics all in one place. If I am doing a project specifically for a customer, I run a data science consulting firm, and so if I'm doing a project for a customer, I'm either going to do that project in R or Python, and if I do it in Python or R, I'm generally going to use a notebook. Now, in Python, for Python, I use a Jupyter notebook. For R, I will use an R notebook, but they both have the same concept. They have the ability to type, I could type in text and explain what type of code that I want to write, or what type of code I am writing, or conclusions that I made from the particular analysis that I've done. I could write code, so I have code cells, and I can create graphics, like bar graphs or histograms or scatter plots, for example, and they'll show up in the notebook as well. So everything will all be at the same place, which I think is really, really important for when I'm presenting my results to my clients. If they then ask me to put it into like a Word document, for example, I will also do that. But generally, the first thing that I show them is a notebook of some sort with code, my conclusions, and the all the graphics that I use to come to that. Okay, so the next thing I want to do is I want to talk a little bit about declaring variables in Python. So just like in R, we can declare variables. And in R, remember, we could use the equal sign or we could use the arrow. In Python, we're going to use the equal sign. So I can say x equals 3. And when I set x equal to 3 and I run the code, it does not display anything. Generally, Python, when you set anything equal to anything in Python, it assumes that you do not want any displayed output. If I want to display what x is, I just type in x and hit enter, and it'll show me that the output, what x is 3. I have now declared that x is equal to 3. Now, Python, just like R, just like any other programming language, has a bunch of different data types. Now, X currently is numeric. So we can type in type. And you can see that X is an integer. Type is a wonderful, wonderful function. It allows you to figure out exactly what you're working with. I use it all the time, especially when I'm debugging code, because when I get an error, more than likely it's because I'm using the wrong data type. Well, I'm either using the wrong data type or I've spelled something incorrectly, because spelling really counts when it comes to coding. Unfortunately, the computer can't tell what it is I was trying to write if I don't spell it correctly. It's not smart enough to do that. So one of the possibilities for a type of variable in Python is an integer. We could also create a string. And to create a string in Python, we do the same thing that we would do in R. We'd use quotes. And the quotes tell Python that we're looking at a character string. I can then type Y, and it says string, because it's a string. Cool. The other type of data in Python, the main type of data in Python that most people use, are lists. Now, a list in Python can hold anything. It can hold a bunch of numbers. It can hold a bunch of strings. It can hold strings and numbers. Lists can hold lists of lists. Lists are extremely dynamic for Python. They are a way that you can hold a bunch of different data. There is one thing you can't do with lists, though. You cannot do math on lists. So let me show you how to create a list. There are a couple different ways. So I'm going to type in a list by using square brackets. And you see that I typed in hi in quotes, so I'm putting in a string. I typed in 3, the number. I typed in x, which is my variable x up here, which is also 3, and my variable y, which is hi. And remember, since I set j equal to the list, it's not going to display anything, but then I can type in j and hit shift enter, and it shows me what's in my list. And I made a palindrome because I used X and Y in my list. Again, the list has both strings and numbers in it, and that's completely okay. Because a list is just a way to hold data. So that's one of the ways you can create a list. Another way you can create a list is by using the list command. Oops. Now H is a list. You can also create an empty list by just using empty square brackets. Now we can use the type command on K, for example, and we still see that it's a list even if it doesn't have anything in it. Now, once we've created a list, now we want to be able to access the things in the list. And the way that we access things in Python is exactly the same way we access things in R, is to use the square brackets and the index. However, in R, indices start at 1. In Python, indices start at 0. So if I want to get the first thing in my list H here, I have to use 0 as my index, because the first thing in my list is actually the 0th thing. All right, let me show you how that works. So H of 0 is my 1. Now, this is the most confusing part for most people who are learning Python, that the indices start at 0. Generally, this is the part that takes forever for all of my students to get. For people who have used a bunch of other programming languages, a lot of them start at the index at 0. So this is not like isn't usually not a big deal for people who have used a bunch of different programming languages. But for people who are new, that the indices start at 0 is a little hard, because we don't usually count starting with 0. We count starting with 1. So if I want to get the second thing in my list, I use the index 1, etc., etc. So the final index of my list here is 3, not 4, even though there are 4 things in my list H. Does that make sense? Honestly, Tavi, I don't know what duck typed means. Can you explain?
Oh, it kind of is. I can see from this. It's just that like things are given a type based on how they're defined and used, rather than having to say like this is that and this is that.
Right. No, absolutely. You're absolutely right. Python automatically assumes type based on what you've put in your list or you put in your variable. You can force type by using different commands like list or array or string, for example. But generally, things are given a type based on what they are.
Yeah, it comes from an express like, if it quacks like a duck, then it's a duck. If you use it like an integer, it just gets called an integer.
Cool. So yes, absolutely, Python has duck typed. That. Okay, so we talked about lists. We've talked about single value variables. Let's talk a little bit about other things in Python, like if statements, for loops, and functions. So Python, just like R, has if statements, for loops, and functions. In Python, the way we tell Python that something is inside a for loop or inside an if statement or inside a function is with indentation. Now, for people who are using RStudio, if you were creating a function or a if statement or a for loop in RStudio, it would automatically indent for you, but it's not necessary in R because you generally have the curly brackets around everything in your function or everything in your for loop or everything in your if statement. However, in Python, the indentation is extremely important because Python assumes that if something is indented to a particular to a particular indentation, that it is inside either the for loop or the if statement or the function, depending on that point of indentation. So for example, I want to write a for loop. I would start with the keyword for. I would create myself an iterator, which for anyone who has used a for loop before, the iterator is just the thing that's going to go through my list of things. I use my keyword in, and then I give Python a list to go through. Because that's how for loops work in Python. They use lists. Now, I could use a couple of different things to do a list. For right now, I'm going to use one of the lists that we have already created. I'm going to use J. So J is my list that has hi, 3, 3, and hi in it. And then to tell Python that I'm done with that first line of my for loop, I put in a colon. And then I hit enter, not shift enter, just enter. And you see that it automatically indents for me. So the next thing that I'm going to do is for this for loop, I'm just going to print everything that is in my list, J. And to do that, all I have to do is type in print and use the print function, and then use the letter I for my iterator. Because the way a for loop works in Python is we have our iterator that goes through each item in the list J, or in the list that we've given it, and the list that we've given it is J. So our iterator takes on every value in that list. So the first time we run through our for loop, I is going to have the value hi. The second time we run through our for loop, I will have the value 3. And so on and so forth. And I'm going to show you what that looks like. And a for loop, remember, is a way to iterate through a bunch of things and do the same set of code over and over again. So what we've done here is we've gone through this whole list, J, and we've printed each of the items in J. So one of the ways that you can run a for loop in Python is you can give it a list you've already created. One of the ways that I generally use for loops quite often is to create a list of file names and use a for loop to import a bunch of files all at once. Or I've used a for loop to save a bunch of files all at once. For loops are used for all kinds of things, but this is what I use them for most. But generally, for loops are used to be able to repeat the same set of code on a bunch of different values. So if you're writing one piece of code that you need to repeat over and over and over again, generally you would either put it in a for loop, or you would put it in a function, which I'm going to talk about in a second. Are there any questions about for loops? There is a command to print it all on a single line. That would just be the print. But it wouldn't do it in the for loop. So if I just print J.
Oh, I mean, like if you're calculating something using a for loop, can you format the output of the for loop more succinctly?
Generally, if you're printing in each run of the for loop, it will definitely not do it on a single line, if that's what you.
Okay. So you should just put it to a variable and then handle the formatting later.
Yeah. Exactly. Okay. So I've done a for loop where I've given it a list that already exists. We can also do a for loop where we give it a list of integers to use as an index. So I'm going to do that now. So for I, and generally when I do a for loop, I use the iterator I, but you can use anything you want as that iterator. You could call it cat, you could call it word, you could call it number, you could call it anything you like, as long as it's not one of the saved keywords in Python. And you can Google the list of saved keywords in Python. But I will say for I in one of the functions that you have built into base Python is called range. Range is used a lot for loops specifically because what it does is it takes in a set of numbers or a single number and gives you a list of numbers based on the numbers that you input. So if I put in just one number in range, I'm going to put in 4. What it's going to give me is the list that is 0, 1, 2, 3. Let me just now it prints out range of 0, 4, but range of 0, 4 is the list 0, 1, 2, 3. So if I want to do a for loop, now I'm just printing I, and I is just going to give me every single value in that range. And you can see that the range gave us a list of 0, 1, 2, 3. You can also give range 2 numbers, a starting number and an ending number. Now range will never ever give you the ending number, because the way range works is it starts with the first number you give it and goes all the way up to the last number you give it, but does not include it. It's like when you were in calculus or pre-calculus and you're creating a range of numbers. You would have a square bracket on the front, but a parentheses on the back, meaning that you didn't include the last number. Range can also be given, so if we do range of 2, 4, it simply prints out 2 and 3. Because it starts at 2, goes all the way up to 4, but does not include 4. Now you can also give range 1 extra input. So right now, range is, if you give range 1 number, the default starting number is 0. If you give range 2 numbers, the default step size here is 1. So it steps through numbers from the first number to the last number, not including the last number, by ones. You can also give range a step size. What? Yeah. So you can also give range a step size that has to be bigger than 1. Where the step size, where it will go through all of the numbers by that step size instead. So let's do 0, comma 4, not 2. So it starts with 0. It steps by 2 to get the next one, but because the ending number that we gave it was 4, it doesn't do the next step because it always goes up 2, but not including the last number in your range. Does that make sense? Okay. So I've done a for loop. Let's do an if statement. So an if statement takes in the other type of data that's in Python, which is a Boolean. So it'll take in a true or false statement, and then it does something based on whether the statement you gave it is true or false. So if and remember we created x earlier, and we said x was 3. So if x is equal to 3, so in Python, if you want to check if something is equal to something by using a Boolean statement, you use double equals, just like you do in R. Whereas in if you have if you are assigning x to 3, you just use a single equal statement. Does that make sense? Okay, cool. Okay, so we've checked to see if x is equal to 3, and then we use a colon just like we do for our for loop. And I'm going to tell it to print x is 3 if x is equal to 3. And because x is equal to 3, x is 3. We can also, up here, say x equals 4 and replace x, replace the value 3 with 4. And you see our if statement didn't print anything because x is not equal to 3. So what the if statement does is it checks to see if this phrase here is true or false. And if it's true, it does the thing inside the if statement. And if it's false, it doesn't do the thing inside the if statement. Now you can add on to your if statement by adding else's and elif. For example, and when you add on the else, you want to unindent. So the else statement here says that, like, if the thing in my if statement at the beginning is false, I'm going to do this thing after the else. Because we set x equal to 4, we print out the thing that happens under the else statement because our check to see if x is equal to 3 was false. All right, so I'm going to pause here and give you some time to play with that. And I will be right back. Okay, are there any questions about if statements and for loops? Okay, so we're gonna move on to functions. Now, if you remember, for those people who were in class last week, you remember that R has a bunch of functions because it's a functional programming language. Python also has a bunch of functions, but most of its functions are built in as methods for each of the different variable types. So, for example, we have our x is an integer. I can hit the dot and then hit tab and see all the different methods that are built in for integers in Python. Denominator is one of them. I can also look at my variable y. Remember, that was the string hi, and hit dot and hit tab and look at all the different possibilities for a string in Python. Now, strings have a lot more possibilities here. One of them is capitalized, so I'm going to do that. Now, this particular function is, or this particular method in string is a function rather than an aspect. So denominator for x was an aspect of x, which means it's just a specific thing about x. Whereas capitalize is a function for a string. And because it's a function, I have to use the parentheses. So you can see that capitalize that first letter in the string that was in y. Strings have a bunch of methods for them. Lists do as well. So remember we had our list J. I'm gonna do reverse. And remember J was high, 3, 3, high. And unfortunately, because it's a palindrome, it doesn't change. But let's try H then. Now we reverse the order of H. Remember, H was 1, 2, 3, 4. Now it's 4, 3, 2, 1. But remember, just because H is a list of numbers doesn't mean you can do any math with it. If I said H plus 3, for example, I get an error. Because plus in Python for lists means concatenate, not add. So for strings in Python, for example, like our y here, let's display what's in y again. So y is high. We can concatenate things to our string by using the plus sign. Y plus this extra string. And then I've concatenated the two strings together. All right, so we've used a bunch of functions. Now let's write a function. So the way to write a function in Python is to use the define function. So you use a function to write a function. And to do that, we use def. We need the name of our function. Call it play. I need the inputs that I'm going to have for my function. And I'm going to say string 1 here. And a colon. So a function, just like in R, functions can have 0 inputs, 1 input, or many inputs, and functions can have 0 outputs or many outputs, or 0 to many outputs and 0 to many inputs. Currently, this particular function that I'm writing only has 1 input, string 1, and I'm calling the function play. Now you see when I hit enter after that colon, it automatically gave me an indentation. If I get out of the indent, Python knows that my function is done. Or that the things that are no longer indented are not part of my function. All right, so what I'm going to get my function to do is I'm going to input a name, and then my function is just going to print my name is, and then add the name on to that string. Now, and once I've created this function, this cell, Python does not know that this is a new function unless I run this cell. Again, the kernel for this particular cell is new every time you open up the notebook. So if you close the notebook and then open it again, the function is no longer going to be something you can use until you run this set of code. So I'm going to run it. And I'm going to use the name of the function, which I called it play. And I'm putting in my name. And it displays my name is red. Are there any questions about for loops, if statements, and functions? Are there any questions about Python in general? Okay. Well, this is about as far as we're going to go today, because I just wanted to give a introduction to what Python is and what it can be used for. Next time, we're going to install a couple of packages if they are not installed already with your version of Anaconda. The newer versions of Anaconda come with a lot of things. So we're gonna install some packages, and we're gonna play around with some more data types specifically arrays and series and data frames. And we're gonna learn how to plot something using matplotlib. Okay? Awesome. All right. Well, for those of you who missed some of class today, the video is going to go up on YouTube as soon as it is available from Zoom. Please feel free to watch on my YouTube channel. It's Veronica Red. Just look for Veronica Red on YouTube. I only have programming videos currently on mine. On my YouTube channel. So if you would like to look at the videos from last week and the week before, which were Introduction to R and Introduction to Shiny, that's totally cool. And next week, probably same time on Friday, we're going to do some playing around with NumPy, Pandas, and Matplotlib. Awesome. Well, thank you so much, everyone, for attending. I really enjoyed all the questions, and I look forward to seeing people next week.
Is next week the same Zoom link?
No, Tavi, I will send out a new one. So if you don't get one from me by Thursday, please let me know that you still want to be in class, and I will. I'll send it to you.
Sounds good.
All right. Thank you.